I now want to look at a few special formulas for factoring. The first is my difference of squares formula. A squared minus b squared is equal to a plus b, a minus b. So if I look at something like 9x squared minus 49, we see that this is a perfect square and this is a perfect square. The square root of 9 is 3, so this is 3x. The square root of 49 is 7, so I have 3x plus 7 and 3x minus 7. The next one is a little bit harder to recognize when we're looking at a problem. We're looking for problems of the form a squared plus 2ab plus b squared. Something like this, x squared plus 8x plus 16. So how we know that it's in this appropriate form, this is a perfect square. So is this. We know the square root of 1 is 1. We know the square root of 16 is 4. We can then multiply those numbers. 1 times 4 is 4. Double it, and it should give us our middle term. So in this case, a is equal to x and b is equal to 4. 2 times x times 4 would be the 8x. So that factors into x plus 4 squared. Very much related to that, all I did was change the sign of the middle term, a squared minus 2ab plus b squared. So if I have 9x squared minus 6xy plus y squared, this term, a would be 3x, since 3x squared is 9x. B would just be y. And then my middle term needs to be 3x times y times 2. That would give me 6xy, and I need it to be a minus. So minus 2 times 3x times y is minus 6xy. So that tells us it's of this form. And we can factor it into 3x minus y squared. While this one and the last one are really hard to recognize a lot of the time, they can be done other ways as well. Just our normal factoring methods will also factor these appropriately. My next one is the sum of cubes, a cubed plus b cubed. And these are a little bit trickier because if we don't know the formula, we can't factor these using our typical methods discussed. So let's consider 8x cubed plus 27. This time I need to know what cubed is equal to 8x cubed, and that's going to be 2x, since 2 times 2 times 2 is 8. B will be 3, since 3 cubed is 27. So when I use my formula, I have a plus b, so 2x plus 3. I have a squared, 2 squared is 4, and x squared is x squared, minus a times b. 2x times 3 is 6x, plus b squared. 3 squared is 9. And you can try to factor this parentheses right here now that it's a squared, but it's not going to work. This would be our full factored form here. Very much related to this, a cubed minus b cubed. So if that middle sign is a negative, I change this to a minus b times a squared plus ab plus b squared. If we look at x cubed minus 1, it might be a little bit easier to figure out b since we know 1 cubed is equal to 1. However, before I write a, I'm going to write this note down at the bottom. X to the 6 can be written as x squared cubed, since raising a power to a power we multiply. So a is actually going to be x squared. When we factor this, we have a minus b times a squared, so x squared squared is x to the 4th, plus ab, 1 times x squared, plus b squared, which is 1. And this time we can go a step further. Because of this parentheses right here, this was our first special factoring. This factors into x plus 1 and x minus 1 times the second parentheses that does not factor. So now I have my final factored form.